Hello everyone. So this is the question from BJT transistor and it is of voltage divider bias configuration, and here it is given that beta is high. This is the current gain. So when it is high, so we can approximate to infinite. So the required value of the resistor R2 to produce the collector current to be 1 milliampere we have to find out. So when this beta is given as high, so we can approximate it to infinite, and beta is defined as the ratio of collector current to base current, and when this is infinite, so it means base current is zero, and emitter current is equals to base current plus collector current for any BJT configuration. So when this IV current is zero, so emitter current and collector current are equal, and it is given as 1 milliampere. So this is the collector terminal, base terminal, emitter terminal, and यहाँ से 1 milliampere is flowing, and यहाँ पर this is the IC that is equals to 1 milliampere. Now this is the base current which is zero. Now this current is zero, so these two resistors are in series, and यहाँ से भी एक current flow हो रहा होगा, let's say I current, and now there are two unknowns in the circuit. I is the current and this is the resistor. So we have to go with the two KVL here. So first KVL we will apply in this loop, and second KVL we will apply along this path from here to here. And this voltage is VB, which is equal to 0.7 volt whenever nothing is given. So we assume VB to be 0.7 volt. And this resistor is given in ohm, so we simply convert it in kilo ohm because all the resistors are in kilo ohm, and we have to find out the value of R2 is also in kilo ohm. So the first KVL, now we are moving in this direction according to this KVL, but the current is coming in this direction, so we have to apply a negative sign here, minus IR2 and plus of 0.7 and plus of this 0.5 kilo into 1 milliampere, which will be 0.5 volts. So this is, and so IR2 is equals to 1.2. So this is the value we have got, and now the second KVL, which will be simply 3 is equals to I into R1 and plus IR2. Right, this KVL 3 is equals to IR1 plus IR2, and the value of IR2 we have calculated as 1.2. So substituting this value here, 1.2 plus of यहाँ पर IR1 and this is 3. Now this will be 1.8 and यहाँ पर this is 60 kilo ohm. So the value of I is 1.8 upon 60 and it will be milliampere. Now this substituting this value I into this expression, so 1.8 upon 60 and into R2 is equals to 1.2. So R2 will be equal to 1.2 into 60 upon 1.8, and this value is 1.2 into 60, it is 72, and divide by 1.8, it is 40 kilo ohm. So this is the answer. So now the second method can be, we can see the Thevenin equivalent of this circuit from here. यहाँ से we can see the Thevenin equivalent from here with VTH and RTH. So VTH will be on this node, and it will be simply the voltage division rule across this R2. So R2 into 3 upon R1 plus R2, and RTH will be the parallel combination of this R1 and R2, but there is no need to calculate R2 because the base current is 0. So VTH is equals to 3 R2 upon R1, that is 60, plus of R2, this is the VTH, and RTH just simply writing like this, R1 parallel with R2, so it is R1 R2 upon R1 plus R2. And now the Thevenin equivalent circuit will be looking like this. This is the VTH, this is the RTH, which is of no need, and here it is the 0.5 kilo ohm emitter resistance, or This is the ground, and यहाँ पर VCC, this is the 3 volt, and 1 milliampere is flowing across this resistor, and this is zero point 0.7 volt, and this is 3R2 upon 60 plus R2. Now simply applying KVL in this loop. So with this KVL, minus 3R2 upon 60 plus of R2, then plus of this zero point 0.7 and plus zero point 0.5 is equals to 0. So यहाँ पर 3R2 upon 60 plus of R2 is equals to 1.2, and 3R2 is equals to 1.2 into 60, that is 72, and plus of 1.2 R2. So here 1.8 of R2 is equals to 72. So we have got the value of R2 is equals to 40 kilo. So these two can be the methods to solve this kind of question. So okay, thank you.